Hi, hello there, lovely one. So we are going through all the calculus questions found in the IEB Paper 1, May 2022. And this is question 12, and it says, in the diagram below, the graphs of and the derivative of x is sketched for x as an element of any real number. And of course they've said O represents the origin, and there it is. And the first thing I notice is that this is a straight line, which means that the function would have been a parabola, and it would have either looked like that or looked like that. So let's take a look at more of the questions. They're asking us to write down the gradient of f at x is equals to 0. And as we can see, where x equals 0, y has a value of 15, so we know that it's going to be 15, and I'm just going to write it down, is equals to 15. But really, I could have just read it off the graph over there. And let's move down. It's now asking us to write down the x-coordinate of the turning point of f. And this is another one we don't have to really show any calculations for. We know that that's going to be the x-intercept. So I'm just going to write down the x-coordinate. X is equals to 10. This last question, what is the gradient of f at x is equals to 1? Well, we would look at the function and we would look for where x is equals to 1, which would be somewhere, let's just draw in a random line. It would be somewhere over there. But of course, we don't know what that's going to be because we don't have formula for the straight line. And now let's just zoom out a little so that we can calculate what the formula is. And I'm going to start with a gradient where we go change in y, so started at 15 and went to 0, over change in x, 0, and then minus 10, so that's going to give us a gradient of negative 3 over 2. And of course we know that our y-intercept is 15, so this equation, f of this derivative of f, is going to be negative 3 over 2 x plus 15. There we're wanting to know what the gradient would be when x is equals to 1, so we would substitute that in, and then we use a calculator, which gives us 13.5 or 13.5. So before we go any further, I want to talk a little bit more about these shapes that I drew over here. So if the first derivative is a straight line, it means that the function was a parabola to begin with. And I drew both of these here, but really only one of them is represented by this. So let's talk about what's happening above the x-axis over here. This is where the graph, the original function, would be going up. And below the x-axis is where we are descending over there. So in fact, this is the right shape for the graph, which means the other one, which let's erase, isn't. This does become useful in the next question when I find it, where it says calculate the point of inflection of f. Well, actually, if it is a parabola, do we have a point of inflection? No, because a cubic function would, it's where it changes from concave up to concave down, and this is just concave down. So there's no change from concave up to concave down, so therefore no point of inflection. And that's really all you have to write for that. And with that, that's it from me. Much love.